The Retort Season 1 presents expert views on the BTWC and CWC and the issues they face. This project is the product of a collaboration between Professor Li Shang, Professor Malcolm Dando and Dr. Brett Edwards. This initiative has been funded by the London Metropolitan University Rescaling Fund 2021, which was awarded to Professor Li Shang. We are grateful for this support.
Hello and welcome to this series of talks on the subject of chemical, biological weapon disarmament and non-proliferation. In this series, we will be hearing from a wide range of experts as we look towards the two major review conferences which will be taking place in coming months. In each talk, you will hear from a respected expert who will outline key opportunities and challenges in making pragmatic and holistic progress on this issue globally. This project has been kindly supported by the London Metropolitan University.
Hello and welcome to what is the final episode in the first season of the Retort. In this episode, we're really lucky to have a contribution from Professor Malcolm Dando and Michael Crowley, who will be talking today about a book they've recently published, which reflects the output from a significant body of work that they've been engaged with for well over a decade. Today's talk focuses on a range of chemical compounds, most notably bioregulators, toxins, and other so-called mid-spectrum agents, which we'll be introduced to in detail in a moment, and their impacts upon international arms control, as well as potential human rights concerns. Basically, this extends to things like riot control agents, chemical incapacitants, malodorants, as well as a range of other agents which have either been employed or considered for application from either a military or law enforcement perspective. As we will see, there are both technical, legal, and a range of political ambiguities around these systems, despite the fact that they've been around or on the horizon for a very long time. In particular, we will look at the impact and coverage of these agents in relation to the Biological and Chemical Weapons Conventions, but also from a broader, holistic human rights perspective. And with that, all that's left for me to say is that I really hope you enjoy today's episode.
In our study, Professor Dando and I explore how revolutionary developments and convergence of the chemical life and associated sciences and disciplines such as neuroscience impact upon contemporary toxin and bioregulator research. We also examine how effectively the Biological and Toxin Weapons Convention, the Chemical Weapons Convention, and attendant measures have addressed risks that toxin and bioregulator dual-use research could be misused for malign applications. We've explored these issues in some depth through 6 country case studies focused on China, India, Iran, Russia, Syria, and the United States. In choosing these countries, we tried to ensure some regional spread and also hope to illustrate the range of contexts and diversity of dual-use research and associated activities of relevance. Although we discovered a variety of activities of concern, I will restrict my presentation to the following areas: dual-use military-related research on toxins and bioregulators, purportedly for protective purposes; dual-use military-related research on novel toxins, toxin production; brain research projects, including those employing non-human primates as models; research and development of incapacitating chemical agent weapons; research and development of malodorant weapons; research and development of riot control agents of biological origin or their synthetic analogues, and associated means of delivery. The country case studies illustrate a wide range of dual-use research and associated activities, including that undertaken by chemical and biological weapons defense research establishments into toxins, bioregulators, associated bioregulatory pathways, and physiological systems, as well as potential measures to facilitate agent uptake and means of external dissemination. The necessity of such defense work is recognized and specifically permitted when it is conducted for protective purposes under the CWC or for prophylactic protection and other purposes under the BTWC. To increase confidence and prevent misperceptions, states should report on such activities through annual CWC Article 10 declarations and BTWC confidence building measures. Unfortunately, public transparency in this area is currently limited. We examined contemporary published scientific papers and other open source information relating to the recent activities of defence establishments and associated biodefence research in the case study countries, and found certain biodefence toxin research of potential concern. For example, in our survey of US biodefence-related research, we found work exploring toxicity of aerosolized toxins, toxin movement across barriers, advanced engineering of botulinum toxins, staphylococcal superantigens function, and use of recombinant technology in SEB production. Due to incomplete publicly available information, the intention behind such research and associated activities is sometimes difficult to determine. It should be noted, however, that even though elements of US chemical and biological weapon defense research are classified, the level of transparency and reporting it undertakes is far greater than many other states parties to the CWC and BTWC. If we now turn to dual-use toxin research by defense or military associated institutions and scientists, our findings clearly indicate that research of potential concern extended beyond that related to previously investigated weapons agents such as ricin, SEB, and botulinum toxin. In several case study countries, we found military and non-military institutions and scientists who had undertaken contemporary research identifying, screening, and isolating novel toxins that had the potential for weaponization. This included those derived from indigenous poisonous plants, amphibians, reptiles, scorpions, and marine animals. In some cases, the stated intent and associated activities were clearly medical or for other protective purposes. In others, the intention was unstated or unclear. In certain cases, the intention appeared to be for toxin weaponization. For example, Indian scientists from the National Defense Research and Development Organization, DRDO, and related organizations published a series of papers on their investigations of toxins derived from native stinging and poisonous plants. For example, in a 2018 scientific paper, the authors argued that because the BTWC banned the use or stockpiling of most of the pathogenic biothreat agents, this will necessitate a search for some novel natural biothreat agents from stinging plants that may be used as future bioweapons for self-defense purposes. The objective of the present research, the authors stated, was to identify, characterize, and screen the potential of stinging plants on the basis of their secondary metabolite contents that may be used for the formulation of novel future biothreat agents for self-defense. A second paper, published in 2018 by scientists from DRDO, describes continuing their investigations into plants that produce toxins that have the ability to adversely affect human health in a variety of ways, ranging from relatively mild allergic reactions to serious medical complications, including death. It highlighted the identification of several poisonous plants that can be used for the development of novel multi-system targeted warfare agents for defensive applications, and then described poisonous components identified from 10 candidate plants and described the mode of action of these substances. They were described as having a harmful effect on various biological systems like nervous, cardiac, digestive, respiratory, dermal, etc., simultaneously. It should be noted that unlike 5 of our case study countries, the Indian authorities did not reply to our repeated information requests to explain the purpose of such research. Another area we explored was toxin production, notably in Syria. In October 2013, Syria declared its existing chemical weapons stockpile and agreed to facilitate its verification and destruction under OPCW supervision. However, certain CWC states voiced concern over the accuracy and completeness of the initial Syrian declaration, including with regard to toxins. Consequently, in April 2014, the OPCW Director General established a declaration assessment team to attempt to resolve many of these concerns, including toxin-relevant activity. In July 2014, the OPCW Director General reported that Syria had declared a CWPF, a chemical weapons production facility. And this facility, which was the Al-Maliha facility, was for the production of ricin. According to Syria's amendment to its declarations, the entire quantity of ricin produced was disposed of prior to the entry into force of the convention. In July 2018, the OPCW reported that the Technical Secretariat had verified the destruction of all of Syria's declared chemical weapons production facilities, and this therefore included the Al-Maliyah facility. However, there is very little public information available on this case, and there appear to be several unresolved questions. Syria previously stated that its ricin production was for medical purposes, i.e. cancer research and treatment. And if that was so, why did Syria not present this information to the OPCW and to the public? And indeed, why didn't it continue with such important medical work, rather than declare this facility as a chemical weapons production facility, which it then had to destroy? We wrote to the Syrian OPCW permanent mission, and in May 2022, they responded stating that all of the detailed information relating to the ricin production program has been fully shared with the Technical Secretariat of the OPCW, and that this included declaring the mentioned program and its strategy, as well as fully disclosing the ricin production amounts and dates, as well as the dates of their destruction. Whilst this was very welcome as a response to us, none of this information has been made public, so we do not know how much ricin was produced, what it was intended for and what it was actually used for, where it was kept, and when remaining stockpiles were destroyed. The next area we explored was potential dual-use activities related to national brain projects and associated research. Over the last 2 decades, the technologies available to neuroscientists have developed rapidly and made it increasingly possible to understand the neuronal circuits in the central nervous system that underlie our behavior, and the roles played by bioregulators in such processes. The obvious advantages of this work, for example, in helping people with brain dysfunctions and injuries, has led states to initiate large-scale brain research projects over recent years. In certain countries, scientists from military medical institutions and other defense-related facilities are involved in much of this research, and we explored this in both our US and China case studies. In China, for example, we found research on neurological systems and associated bioregulators in a variety of simple animal models that have potential dual-use applicability. In addition, in order to better understand more complex human behaviors and the mechanisms that produce them, work is also being carried out in China on non-human primates like macaque monkeys. A 2016 lecture from one of China's leading researchers highlighted the goals of non-human primate research, which included, inter alia, studies of the cognitive functions using non-human primates as the animal model, and generation of genetically modified, including transgenic monkeys, as animal models of human brain disorders, and for basic neurobiology research. The research seeks to explore the neural basis of cognition, including how molecules and cells establish synaptic contacts and generate neural circuit activities. This research has, for example, included work showing that monkeys can be taught to pass one of the standard tests used to detect if animals possess self-awareness similar to humans. The lecture also discussed adaptation of genetic manipulation technologies, notably growing monkey testes in nude mice and regrafting them so that the monkeys came to maturity and could be used in further genetic manipulations much faster. Whilst the purported purposes of such research are benign, there are risks of potential malign application, including to inform or facilitate development of bioregulator weapons to attack, subtly influence, or subvert human cognition, feelings, and actions. The next area I'd like to turn to is with regard to incapacitating chemical agents, which have also been described as central nervous system acting chemical agents. They are a disparate group of toxic chemicals whose purported intended purpose as weapons is to cause prolonged but non-permanent disability or incapacitation. They include centrally acting agents producing loss of consciousness, sedation, hallucination, incoherence, paralysis, disorientation, or other such effects. Many putative agents have low safety margins. Inappropriate doses cause serious, sometimes permanent health effects and may result in death. Chemicals of biological origin and their synthetic analogues have been amongst the substances explored as potential weapons, and we looked at such research, particularly in China, Russia, and the US. If we take the example of Russia, until its collapse, the Soviet Union undertook research and attempted development of CNS-acting weapons employing both pharmaceutical chemicals and bioregulators. During the 1980s and 1990s, according to high-level whistleblowers, it explored potential CNS-acting bioregulator weapons, including endorphins, enkephalins, and other neuromodulating peptides, potentially capable of altering human cognition and emotions. One whistleblower alleged that the mood-altering possibilities of regulatory peptides were of particular interest to the internal security forces. It is unclear whether all such activities terminated following the change in political system in Russia. Subsequently, in 2002, Russian security forces employed an aerosolized CNS-acting pharmaceutical chemical weapon in a large-scale anti-terrorist operation. Russian dual-use research into pharmaceutical chemicals with potential CNS weapons application has subsequently been reported. Russia stated that law enforcement use of CNS-acting weapons is not regulated by the Chemical Weapons Convention. It also rejected the legitimacy of last year's CWC Conference of State Parties understanding that law enforcement use of aerosolized CNS-acting chemicals was prohibited under the Chemical Weapons Convention. In China, by contrast, state-owned companies have developed CNS-acting weapons for use against individuals rather than for groups. And such weapons have been documented in the possession of the Chinese military in 2011. These CNS-acting chemicals have not been identified, and it is unknown whether research and development of bioregulator CNS-acting weapons has occurred. Like Russia, China rejected the legitimacy of the CSP understanding of this issue. Malodorants are a disparate group of naturally occurring and synthesized chemicals affecting the human olfactory receptors. When employed as weapons, they are intended to elicit short-term and temporary physiological effects or behavioral responses. Candidate malodorants examined, as well as those utilized to date, typically elicit strong aversion or avoidance responses in those targeted, whilst physiological responses can include nausea, choking, gagging, and vomiting. In the US, defense and defense-funded projects researched and explored development of malodorant weapons, apparently investigating both naturally occurring substances and synthetic chemicals. The military also undertook or funded projects to develop a variety of delivery and dispersal mechanisms. From 2004, a US commercial company and military partnership sought to develop a 155mm malodorant artillery round. This munition encased multiple submunitions which were intended to be released above the target area, falling to the ground on parachutes and dispersing their malodorant payloads as they fell. It had a range of at least 20 kilometers and covered a minimum of 5,000 square meters. The project was suspended in 2008. Subsequent US military interest is certainly indicated by solicitations made in 2011, 2014, and 2021, requesting industry proposals for projects to develop malodorants and dispersal mechanisms. No details are publicly available as to whether and how such solicitations were taken forward. Malodorant research has also been found to have been undertaken in India, including by DRDO scientists. In addition to state research, at least one commercial company in the US has until recently promoted a malodorant skunk weapon to law enforcement and military forces. The company described it as an organic solution developed in conjunction with police forces of unnamed allied countries. It can be sprayed over a large area using a standard water cannon or launched in less lethal type munitions to achieve greater distance and a combination effect. The US company promoted a range of attendant delivery systems, including a 40mm less lethal grenade and a skid sprayer with a 50-gallon tank that has a range of over 60 feet and dispenses the skunk malodorant at a rate of 7 gallons per minute. To date, there has been no use of this malodorant weapon reported in the US. However, there has been repeated confirmed use of a skunk malodorant weapon by the military and police forces of another state, not included in our study, i.e. Israel. Such use has been in disputed circumstances. Human rights organizations and international media have reported repeated excessive and wide area use of such skunk malodorant weapons. In some cases, it was claimed to have affected the health of those targeted. Riot control agents, RCAs, are defined under the Chemical Weapons Convention as chemicals not listed in the schedule which rapidly produce sensory irritation or disabling physical effects which disappear within a short time following termination of exposure. However, RCAs employed in large amounts or in enclosed spaces can cause serious, sometimes fatal health effects. RCAs that are commonly employed in law enforcement include a number of biological origin, notably oleoresin capsicum, OC, and related substances, and a chemically synthesized analog called PAVA. In China, India, Iran, Russia, and the US, we found indications of development by state entities, state-owned companies, or commercial companies of delivery mechanisms capable of disseminating riot control agents, potentially including RCAs of biological origin, over large areas or extended distances. For example, 2 US commercial companies have promoted an indoor RCA dispersion system that will provide critical force protection for personnel and facilities by use of remotely deployed tear gas as a deterrent to control disturbances, uprisings, and riots in any facility where protective security is required, whether it be prisons, government buildings, or embassies. It has also been promoted for external area denial. The basic unit can operate and discharge up to 25 tear gas dispensers selectively, and larger facilities can use multiple control units and dispensers to accommodate their security needs. The marketing material has indicated that CS or OC dust can be employed in the system. Another US commercial company developed and until 2016 promoted a powerful spray and fogging device. Its marketing material stated that standard non-toxic training smoke mixed with irritants such as OC or pepper upgrades the capabilities to include inter alia crowd control and civil unrest and urban warfare. We found at least one Iranian company that markets riot control agents that had been reported to have promoted a delivery mechanism of potential concern. In its 2020, 21, and 22 CWC compliance reports, the US asserted that this company had provided fact sheets to interested users on a fog maker system that can be used to make smoke and fog at high volume in a short time. The US compliance reports include images from an undated Iranian advertisement for a fog maker mounted on a speedboat and on a truck. According to the US, this is noteworthy because it can disseminate debilitating chemicals, like the riot control agent CR, over a large area quickly. Although no technical specifications are publicly available, this system appears potentially capable of dispersing a range of riot control agents, including OC and its synthetic analog, over wide areas. According to a report by AFP, in 2015, police in the Indian state of Uttar Pradesh acquired 5 unmanned aerial vehicles incorporating a pepper spray delivery mechanism. The UAVs can each reportedly carry 2 kilograms of unspecified pepper spray and can be flown within a 1 kilometer radius of their operator. The police chief stated that police had successfully test-flown the UAVs, which he explained were intended for use in crowd control situations. In 2018, the Hong Kong police acquired 3 German-manufactured water cannon vehicles, each containing 2 water spray devices capable of employing large quantities of water that can be mixed with a riot control agent and/or a dye, and can target individuals or crowds up to 50 meters away. The Hong Kong authorities reportedly confirmed that the riot control agent employed was PAVA. From August 2019, there were repeated reports of police employing water cannon firing water mixed with blue dye and/or PAVA against protesters in disputed circumstances. In the previous examples, apart from the Iranian case, the manufacturers specifically highlighted the capability of their delivery mechanisms to disperse OC, parva, or pepper spray. In addition to these examples, there are an increasing range of additional wide area RCA means of delivery that could potentially be utilized or adapted for delivering such agents. They include multi-barrel launchers, automatic grenade launchers, large caliber munitions, heliborne dispensers, and unmanned ground vehicles. This is clearly a broader area of potential concern requiring further attention by both the BTWC states parties and the OPCW. Thank you.